Hey everybody, my name's Peter Marshall. I'm a technology evangelist working with the open source community here out of Imply, where we're helping anyone who's trying to adopt Druid. We're always looking for advocates who want to talk about Druid a bit more. And we're helping everybody who is trying to understand exactly what it is that Druid does. If you want to know more, email community@imply.io. In this talk, I'm going to uncover a little bit about hot pipelines. What is it that makes this data river that people have been talking about hot and so cool? To do that, we're going to have a little bit of a recap of where Druid lives in the data river, in the hot data pipeline world. We're going to talk a little bit about hot data sources for Druid and give some examples of those out in the community. And we're also going to look at the kind of processing that needs to happen in Druid to speed up the user experience that we're creating. So, where does Druid live? Well, this is a beautiful scene. This is a geyser. What is a hot data pipeline? I think it's kind of a bit like this. Geysers work because water that's just sat on the surface of the earth, maybe in a lake, works its way down into the surface of the planet, down to a depth of about 2,000 meters, 6,600 feet. And down there are these hot rocks, and the water fizzes, it boils, and the pressure of that reaction pushes the water up and up and up as hot water and steam. Now, it doesn't just spray out of the surface. That's a bit boring, right? It actually explodes out. It propels that water into the air in this amazing spectacle, this hot data spectacle. The source data is heated. The engine treats it and heats it even further, and the spectacle that we see is really awe-inspiring. You see, it's hot at the top, it's hot in the middle, and it's hot at the bottom. If you've seen the talk Some Like It Hot by Gian Molino or by Rachel Podresky, they describe what these hot user experiences are like for the end user. The query response times they get are between 0.1 and 3 seconds. They're full of fresh data, and because they're attractive, they're used by lots and lots of people. And those experiences are very personalized, they're very interactive, they're very Gen Z. And in the Apache Druid Powered By page, you'll find links to loads of examples of where people have built these kind of user experiences. And don't forget to check out the Imply blog too, where our customers and community members have given examples of the kinds of experiences that they're building. Now in the middle, we've got this engine that's producing this steam, this spectacle that needs to be powerful. It has to cope with the mechanics of creating this thing, a real powerhouse, a machine that's built to do this and only this. We're not building fountains for Chatsworth House, we're building geysers. And that engine has to be useful to us. We need to ask questions flexibly. We need to be able to scale the volume of the data and to deal with the velocity of the data. We have to have good interfaces for you and I to build these interfaces with. We need to be able to retain the data. We need to tier the data. We need this engine to be parallelized, right? Where our queries are parallelized, and we need it to do that job scalably. And importantly, has to optimize the data, has to do something to the water, if you like, in order to do this job effectively. Now, underneath that is hot data. These things are fed by jet fuel down from the earth, down in the souls of our businesses. And yes, it could come from a data lake. Yes, it could come from a database. But really, truly, what we want to have spurting out the top here is data that tells us about what just happened. The latest data, the latest information about network traffic, the latest information about energy production in solar farms, the latest information about financial transactions, the latest information about how well something is streaming on our mobile devices. That means that the final component in our hot data pipeline needs to make the right data accessible to the engine. It needs to be able to protect the latency from where the data is produced to the actual person's desk. And it needs to also, importantly, front load some of the repetitive query time work that would otherwise stifle our ability to build this user interface. So let's get a bit more technical now. Where does Druid actually fit in this hot pipeline, in this data river? Well, Fangjun Yang, who's one of the members of the original Druid development team and the CEO of Imply, describes Druid as a query accelerator. I kind of like that. I started to call Druid an acceleration database because of that. He says that typically Druid sits after your data lake or message bus, and it provides the analytics engine that powers applications with sub-second statistical calculations combining real-time and historical data. So downstream of Druid, the last mile to the decision maker, we could say, we might build a custom application with React or Angular. We might have desktop applications that have Druid support built in, including, of course, Imply's own pivot application. We might have data scientists with notebooks or using weird languages like R that I never had the chance to learn because I'm old. We might do predictive analytics. We might do anomaly detection. The key thing is that all of these applications are there to be powered by hot data, and we want the experiences themselves to be hot as well. And to do that, I can connect Druid to long-term storage systems like S3, like Google Cloud Storage, like Azure Blob Storage. I can even pull in files over HTTP or from local disk, or I can connect Druid even to itself to accelerate that data. But the cool stuff, the really awesome stuff that we want in our geyser comes from streaming platforms like Kafka and Kinesis and Pulsar. We mustn't forget that very often there has to be some kind of processing that happens on that data. Maybe we'll use Spark or Flink or Beam or something like that. You see, ETL hasn't really gone anywhere. If you are a follower of me on the Racket, you'll have heard Rachel and I talking about ETL a couple of weeks ago and how ETL has changed from these kind of like long-running 2-year projects filling up Vertica with data or shoving it into Microsoft SQL Server data warehouse. It's moved now to an agile world, and because it's agile, we have to rapidly develop it and we have to rapidly process the data as well. ETL hasn't gone anywhere, folks. So think of Druid then as this acceleration database. It optimizes the data you give it, and on top you build these spectacular applications. Underneath, it's the job of data lakes, warehouses, databases, but importantly, event hubs, together with Flink and Spark and KSQL, all those kind of good things, to keep it fed with the right data at the right speed. So let's take a look at some examples of how this comes together in the real world. Here's an example from the International Journey of Engineering Research in Computer Science and Engineering. It's from back in 2017, but the principles are the same. Here you can see they have NiFi and Kafka, and they're using Beam on top of Flink to handle the processing. Druid is this acceleration database. It's storing the data. It's allowing analytics for this hot user experience, which this time is for data scientists. And yes, even Netflix has this kind of architecture. I mean, shock, really. Notice that here they have a connection from Kafka through Flink to S3, but there's also this magical connection direct from Kafka into Druid. Do go and have a look at this video, because in the talk that follows this one, the same meetup, Netflix actually also recommend carefully thinking about data formats, another thing we'd kind of associate with ETL. Here they convert to Avro from JSON along this route. Here's another good example of that. Take a look at this video from Virtual Druid Summit 4 by the Lift engineering team. This is their pipeline. Here they're using Flink. They like its APIs, its UDFs, its good SQL support. Flink is used to create protobuf for Druid through Kafka. And in their case, unlike Netflix, they chose Parquet over JSON for the fast lane to Druid, as well as via S3 into the slower lane, into Presto. You see, Presto is just one option. Of course, there could be others like Trino. If you want to learn a bit more about how Druid coexists with Trino, go Google the recent talk that we did with them. But here again, Druid is in the fast lane, right? It's the geyser. This is the hot data pipeline that's feeding this interactive exploration of the data and this really cool UI. The other lane, where other databases are, they do other things. They're doing more complicated things, things that we're happy to take time to do, like not power an interactive UI. If you want to find other examples and stories, check out the tag browser in the Druid forum. We launched this recently, and the list of things there is growing as people find it. You can just fly around from one technology to another and see how Druid works alongside them. So here's Druid, our acceleration database. It's going to help us create that geyser you can see on the right hand side, and at the other end is the fuel, the data. However it's produced, we're going to feed with Druid. First of all, we have to get the data and we have to transport it properly. And not just any old data, but data that's made for geezers, not for making yawn monthly financial reports. And when we have it, we have to propel it at hyper speed. We don't want to put it into a data lake and then look at it once an hour and then maybe add some numbers up. What we want to do is process it now. We want to move it on quickly to our end user. And yes, you could put cold stuff into Druid. Yes, you can fill it with orders data and generate weekly sales reports. But the exciting stuff is billions of events flying through this hyperspeed hot data pipeline that you're building. This data gets into people's brains. It affects how they feel. It informs their passions. This is the revolution in thinking. This is how Druid is helping everyone make better decisions with user interfaces that don't have apply buttons. That means Kafka and Spark and Flink and Kinesis and Pulsar communities, anyone wanting to use Druid needs you. They need you to show them the way, a way where they don't pump events into data swamps, but one where statistics-ready data is queryable directly and immediately. Here's some examples of things you can do for them. You can harmonize the source schemas with the actual target schemas. We talk about that a little bit more in a moment. You might pull data processing back from query time, freeing up your resources from the geezer doing it earlier. You lay out the source data properly so it can be accelerated well. And importantly, you can be that source for data. So when does Druid need event hubs? It's a trick question because anyone building geezers needs a hot data source. They need hot processors. They need a hot engine. For me, of course, that engine is Druid. You need to source the data, to propel the data without delay to create these geezers. So let's look now at some specific tactics. We're going to look at some elements of a typical query, and we'll build up a list of things that you might want to do upstream, as well as highlighting what Druid can do for each one. So let's first of all talk about the dimensions, the things we're going to put in the select clause. Well, at ingesting time in Druid, we can specify the dimensions we want to include from the source. We can exclude dimensions. We can even let Druid just automatically create the schema as it's ingesting. On the upstream side, you might provide wide and narrow sources for different use cases. Let's think about that. What's in your end user experience? If you want to be spectacular at something, we have to be lean, we have to be honed, we have to train ourselves well. When the incoming data is bigger, Druid needs more resources both to ingest it, to balance it, and to accelerate it. Druid is columnarized behind the scenes, it has secondary indexes, etc. So there's already a lot of optimization going on, but the problem comes when we as engineers throw in dimensions that have little to no value, where we treat it like a data lake and not like an acceleration database. Some simple stuff like, well, look at noses. Everyone has a nose. Why do we need to put that in the data? And if I build a UI to count the number of distinct visitors, do I really need both the visitor and the car registration number? And if city is never counted or filtered or grouped by, why is it there at all? It sounds a bit daft, right? But my personal habit is just to work through the elements of the queries that I'm going to run in the UI. I look at the select, the where, the group by, the order, and then I look at the calculations and the aggregations, and I assign the columns a value. Yes, it's true. I even have spreadsheets to help me do this. Let's just remember, Druid is not a data lake. It's an acceleration database. It's a geezer maker. Staying with the select clause, in Druid we can execute expressions, which is nice. We can do that at query time, but we can also do it at ingestion time. And it also raises a question, well, maybe some expressions I need to evaluate earlier. We all love maths. Well, actually, not all of us. I'm actually quite rubbish at maths. But those who love maths, turn this into a bit of a maths question. What is the cost of doing the calculation you want to do every 5 milliseconds with every query that executes versus doing it once at ingestion time, or doing it upstream? And does the cost of doing that justify the value that you're giving to your end users? So let's play this out a little bit. Imagine I do a select to calculate the degrees Fahrenheit from the degrees Celsius in this data, and then I get the average over a time period. Now, I can do that at query time in Druid, and yes, it's going to be really, really fast because that's a really stupid example. But we have to think about those 1 million users who are going to execute that query 1 million times a day. I could cut out some of the processing that Druid has to do by doing the maths, that conversion, at ingestion time. And it's especially true here because the end user doesn't manipulate that calculation in the UI. None of our users are about to change how you convert between Celsius and Fahrenheit. So why waste energy doing that at query time in your geyser? Do it ahead of time. Do it at ingestion. Or maybe if it's a complicated calculation, you've got to refer to other things, or maybe you're going to use that data somewhere else in your data ecosystem, do it upstream. But maybe your UI is letting them build up some math in some kind of interactive way. The question you are then faced with is, do we get Druid to do that calculation at query time, or do I do that inside the presentation layer, for example? So what kind of expressions can I run in Druid? At ingestion time in Druid, you can use the transform spec, it's called, to perform these row-wise calculations. I can have conditions, I can manipulate arrays, a series of time, math, and string functions. I can do things with regular expressions. I can do lookups to key value tables. I can even run some custom JavaScript if I want. Now, here's one that really matters, this lookups thing. In Druid, you can take a key, say the HTTP status code for an incoming request, and I can dereference that to a value, say a nice friendly description. So the same question applies to that lookup as it does to all the other expressions. Here's an example where we're using those HTTP status codes, we're doing a group by, and then we're doing a lookup, all at query time. But guys, HTTP status codes don't change anytime soon. We could quite safely not use a query time lookup for that, fast as they are. You could do it at ingestion time or even upstream. So now, because we know the result of the expression we will get on the UI is settled at ingestion time, we can shift the lookup expression to be evaluated at ingestion time, and we enrich the table instead. Now, 1 million people are not going to cause 1 million lookups to be done, just like with Celsius and Fahrenheit. That settled thing is really important. Because what about a person's name? Like a visitor's name? If you evaluate that at ingestion time, it becomes immutable. It becomes part of the data source. So that's the value you're going to get at query time every time. And you may end up then in a land of wanting to do row level updates. But you can do the lookup at query time. Now you'll always get the latest value from that key value store at query time, if that's what you want to do. Let's turn to the where clauses, specifically like filtering rows out. So Druid have these great secondary indexes. They're really important. They're a big performance differentiator from, say, a query engine sat on a data lake. But we can also do ingestion time row filtering. Now, that means that we can filter rows out as they're ingested, but we may also think about doing something upstream. We may provide short or long sources for different use cases. So, imagine you're building this super user experience where the end user only wants to ever see these 500 HTTP errors from a stream of, let's say, 1 billion events a minute. Or maybe they only want to know about suspect transactions that are going on in your bank. Well, I can apply this filter at ingestion time in Druid. I don't put it in the where clause in the query. Instead, I create a table that only contains these rows. This is just another great way of front-loading energy that will be put into evaluating it at query time by our user horde, and instead doing it at ingestion time. Now, a side note here, if what Druid does for you, add ingestion time when it comes to filtering, doesn't cut it for you, let's say, for example, you want to do some kind of weird, complicated sampling, then, of course, you need to do that before Druid, but I guess that's kind of obvious. But remember, Druid is going to read every message from the stream. It's then going to accept it or reject it. So if just one of your 7 billion rows per millisecond match the filter, you still have to give this acceleration database the power to read all of them, even if you just want one row. So upstream, you might decide to reduce the burden on Druid, filter them out upstream instead. The where filters are also critical for another performance hit in Druid. When the data is ingested, individual tasks, of which there could be many, are watching a number of sources. In Kafka, for example, that's a number of partitions in a topic. The data is then sharded by time at a granularity that makes sense for your data, the ideal being individual shards or segments with about 5 million rows in. That means it can do time-based segment creation and query time pruning, all based on time. But we can also take that data and apply a secondary partition that can also then be used to prune what segments are picked up. That means that the data that's actually picked up and accelerated is determined by two things, by time and by the subpartition. First of all, that explains why Druid queries always have time in them. It's the primary partitioning technique for the underlying data. It allows the hungry hippos that are going to nom 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 all through the data to pick it up very quickly and work out what to accelerate. That performance boost is for free. That filter is applied right at the very bottom in the data nodes, and it's important you know that because very often people don't think about applying time filters in Druid, but I'll tell you now, make sure you always do. It's so many times where people I've seen come up against performance challenges. They just haven't given Druid enough oomph to handle the length of time that they're querying over. And that's why sometimes the solution is to build that user experience to deal with small, discrete periods of time, rather than, say, 30-day or 90-day or annual blocks, and asking Druid to accelerate the whole lot. In fact, this is the approach that we take with Imply Pivot. We do lots of very small, high-speed queries that together build up the view that the user wants and don't overwhelm the cluster. Second, that's secondary partitioning in Druid. Let's talk about that a bit more. It's really important. You need to think about whether there's a dimension in your data source that's a common where filter. And if there is, consider how you're going to use that dimension to sub-partition your segments to make the process of picking up the data to nom 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 through even more efficient. Now, a bit of a soap opera example that begins these filtering considerations into focus is multi-tenant. Maybe, for example, you're going to use the design pattern where you have one large table data source and you're going to use a where clause to get data for different tenants. Well, here you want to make sure your sub-partitioning is nice and in order so that you get pruning right down at the segment level. Upstream, you'll have one topic that feeds into one table. You need to think about how you're going to apply sub-partitioning effectively and how you're going to make sure that your partitions, these segments, are nice and balanced. It's getting answers to questions like that, of course, which is why Imply engineers and support people have been working in this kind of region for years with some big names. So come and speak to us on the Druid forum or to anyone in the team so we can put you in touch with the experts. I think you're kind of getting an idea now. I've been talking very quickly about a lot of things for a while, but the general picture is that we need to be lean about what we accelerate through Druid, both width and length, and how you need to think about the query you're going to execute specifically on this specific data source for that specific audience. Sometimes you might need a hyper-lean table, one that's blindingly fast and where you're sub-partitioning the data very carefully, where you're using approximation techniques. And then you might have another table which is a bit meatier, a bit beefier, a bit bigger, a bit more like the Hulk and a bit less like Spider-Man. You see, Hulk needs a lot of energy to accelerate. Yes, he's powerful. Yes, he has everything that we could possibly need, but he does require a lot of energy to get going. One final thing out there, if you do a lot of in statements, do go and check out Bloom filters. Now, data sources in Druid are from clause. Well, they're called table data sources technically in Druid, and there are other types of data sources as well. Table data sources encapsulate some really interesting configuration and functionality, like, for example, that's where we set the retention periods, it's where we set the task replication, it's where we set up configuration for automatic compaction or defragmentation to us old boys and girls. So that means upstream you might split sources according to different information and information management requirements. One example could be that one of the sources that you have is critical to the business. So you need maximum redundancy in Druid at ingestion time. You might increase the number of replicas within your event hub. You might maximize availability and spend tons of money on it. Whereas other data, well, you might not care about that so much. You might have S3 as a backup plan anyway, and you'll just re-ingest if it doesn't work. And in Druid, you'll have a different table, therefore, that's got a lower SLA or OLA. A note on streaming ingestion in Druid. As you scale up, Druid is going to balance work between each of the subtasks that are monitoring your event hub. So to keep ingestion nice and healthy, we really want the volume of data in each partition in our topics to be well balanced as well. So in high volume situations, I've seen people use key hashing, for example, to get nice balances of each partition. Now, the most important thing on this list is the last one, it's compaction. If you have data that's going to be late arriving, or it could be out of order, and you can't do anything about that upstream, Druid's compaction system will make sure that you don't end up with lots of tiny shards all over the place clogging up the pipes. If you have a producer that's prone to this, you might decide to make a separate table where you can manage it separately. One more little note, you can do union operations in Druid, just take note that it works best when schemas match between the sources. Okay, on to aggregates. This is what Druid's amazing at, group by operations. Min, max, sum, average, all that cool stuff. Now, of course, you'll be glad to know you can do this at query time in Druid, thank goodness. But you may not know that it's possible to do them at ingestion time, where we can generate aggregates. And this is a really important technique in Druid. We can create windowed aggregations, we call them metrics, by truncating the incoming timestamps of our data, and then we basically do a group by star before it's written. Now, the result is a massive performance improvement. There are lots of math things that happen in Druid that make operations on this summarized data more efficient than doing it on raw data, let alone the fact that we have a massive reduction in scan times. Now, a note from Netflix. That hashing thing we were talking about upstream to balance the topics, well, Netflix actually hash all the incoming dimensions so that when this rollup happens inside these individual concurrently running jobs we have, the work that Druid is doing is absolutely symmetrical and extremely lean. So, hot data pipelines, that's the Netflix example. Now, as we saw with expressions, you need to ask yourself, for this spectacular thing I'm building, can I front load some of these aggregations? Can I do them at ingestion time? You know, there's a reason you don't do a min on 10 million rows over a particular period in your presentation layer. You hand that off to the query engine. And with the Druid query engine, you can ask the same question. Why am I doing this at query time over and over again? Can I hand it off to ingestion? And of course, you might even hand that ingestion work off to something upstream, like in Flink or Spark. You could provide source data to Druid that's been pre-aggregated. Just as with expressions and lookups, the question is always going to be how flexible do you want the UI, and when is the result of the expression actually settled? Druid has had support for Apache data sketches since before they were Apache data sketches. Approximation is a really critical technique. If you don't know about it now, you need to go and read about it. Go and learn about hyperloglog and quantiles and theta sketches. It really is one of the really most important techniques to deal with hot data pipelines at this scale. Now, in short, what they do is they take high cardinality data like a list of IP addresses, they squish it up, they do some magic, and they create something that's infinitesimally smaller than the original was and still allows us to do highly accurate count distinct set operations, calculating of percentiles. Druid can create these at ingestion time like any other aggregate. We create those in those time windows, and it also is intelligent enough to use them at query time whenever it can. Imply pivot is also intelligent. It automatically recognizes approximates when you build dashboards and data cubes out for end users, so they automatically get the speed boost from having used them. Now, you upstream might want to generate them before they reach Druid. Maybe you need to create these structures, these sketch structures, using something other than what Druid does, which is the timestamps. Maybe you need a set of specific visitor demographic group members that you can union with one of these sketches. I'm not going to get into the details of that. Instead, I'm going to refer to a fantastic speaker, Itai Yaffe, who used to be at Nielsen. His series of talks on data sketches are awesome. Do go and have a look at those instead of listening to me. And then there are joins. Now, the join engine in Druid is constrained in what we call the execution pyramid. It occurs right at the very top, where there are constraints on access to processing, memory, and disk resources. So, this means that one of the most important needs for pre-processing in our hot data pipelines is denormalization and enrichment. It allows Druid to accelerate much more effectively. Maybe enriching user actions with campaign data or adding visitor demographics to those user actions. Anywhere that you want to do more than just dereference a value by using a lookup. To quote someone we've been speaking to about the Spark connector for Druid, let Druid be Druid, let Spark be Spark. Druid is the geyser maker. It's the acceleration database. Let's make it as easy as possible for Druid to do that for us. So if you can, always query from one table in Druid and fill that table with stuff that's already been enriched and joined. Similarly, talking about that constraint, do also be aware that subqueries in Druid are also constrained currently at the top of that pyramid of resources. So if you can, also avoid using subqueries. This is a handy bit of KSQL that will do the kind of enrichment that we're talking about upstream. Here, each stream of data is a topic with metadata, and we have clickstream data flowing through the pipeline. Then there's a left join to a web users table. That's giving us the latest version of records for each user. It creates a joined stream, which is enriched with location information from the users table. And then Druid, just like any Kafka consumer, can now subscribe to the output stream, that enriched clickstream stream, just like any Kafka source. And it lets people explore, drill down, filter, all that jazz through the hot analytics UI. A short side note is that funnel analysis experiences can be really cool built on top of Apache Druid. People can filter at all the different levels of the funnel, they can compare different periods, lots of really cool stuff. All the successful user experiences that have been built with funnel analysis are based on order being implicit when the data gets into Druid. The order isn't calculated somehow at query time with some weird collection of forestry subqueries. If you're doing that, make sure you look at theta sketches as one possible technique. There are others too. Feel free to quiz me on that on the Druid forum or any of us here at the team. Last on our list, Windows. Of course, I don't mean Microsoft Windows. Yes, you may be able to do some windowing work using queries, but sometimes it's better to do it elsewhere. When a query executes in Druid, the different nodes executing on their particular part of the data don't talk to one another. It's a fan-in, not a shuffle. So imagine you're ingesting 10 million rows using 5 tasks. Each task takes every other row, round robin, out of Kafka. That means the rows are not next to one another. They're distributed. That is the nature and the result of a distributed ingestion system. Asking Druid to subtract the value from one row with a value from a previous row is computationally very complicated in a distributed system. But yes, there is a PR for lead and lag and so on. So if you're interested, please do go onto GitHub, thumbs up that PR. So for now, if you need them, you may need to just do it upstream. Just be aware of what windowing aggregations you can do in Druid. Secondly, state. Druid is not a state store. It is not an OLTP. It's an OLAP database. It's here to create geysers. If you need to maintain state, if you need to do frequent updates, think about doing that somewhere else. You could tell Druid about the changes. You might build a Delta event architecture. That's the solution I've seen for sessionization, for example. But remember that Druid is about getting stuff out as quickly as possible to create a spectacle. Fast in, fast out. Just on the topic of sessionization, it's a very common thing to do in Clickstream, whether that's video streaming or looking at web analytics. There's a tutorial from Confluent on how to generate a second stream of data that contains a full session information that you can then pull into Druid for people to look at. What does that do? Well, it gives Druid two data sources that your end users can then play around with. One for, say, clicks, one for actual sessions. But they get it as quickly as that information is true and relevant and complete, which is what we want in a hot data pipeline. And finally, please remember, Druid becomes part of your pipeline. Think about how you're going to monitor the connectivity. Think about how you're going to exercise change control. Maybe you need to think about Jenkins and Git and all that good CI/CD stuff. You need to remember the impact that changes in the technology or in your configuration are going to have across the entire pipeline, of which Druid is going to become a critical part. So here we go. Nice summaries. Think about wide and narrow sources for different use cases. Think about performing calculations upstream if you can. Think about short and long sources for different uses. Splitting your sources according to information management requirements. Definitely get into the weeds with Apache data sketches. Think about denormalizing and enriching upstream. Thinking about minimizing the number of joins and subqueries you have to do. Think about applying any really complicated windowing calculations upstream, and importantly, handling state upstream. So what can you do then? You can opt to partition, calculate, enrich, correlate, bifurcate, transform, all that cool stuff that we knew about ETL years ago. You can think about doing that all upstream. Why? Because it's about the timeliness of the delivery of those calculations through this excellent engine that we have to build these amazing experiences. Thank you very much for your time today. If you haven't downloaded Druid yet, go and have a look. Go to the Druid project site. There's a quick start guide you can follow to install it really quickly and ingest some data. Of course, there's lots and lots of docs there too. If you're an engineer, do go and have a look at GitHub, star the repository, have a look at the issues, have a look at the requests, the PRs, and of course, do come and join us in the community. There's the Druid user forum by Imply. There's the Druid professionals group on LinkedIn. Come and say hello to us in there. There's lots of Imply organised Druid meetups. And follow, of course, Druid.io and the hashtag Apache Druid on Twitter. We look forward to speaking to you. Thank you.